Hello everyone. Through this session, let me explain how to wire large appliances at home. A few appliances that we use at home are the refrigerator, geyser, oven, which are going to consume more power when compared to the light loads. So we use a power plug for that, and normally a power plug comes with a switch and a socket, a 5-pin socket. And at times we could also see power plugs along with a fuse, an inbuilt fuse, and a indicator lamp. So let me first explain the wiring at the outset, and then let me explain how to wire within the power socket and a switch. Okay, so we have the supply taken from the electricity board, which is getting into our premises through the energy meter, and from where we connect it to a circuit breaker. So from a circuit breaker, okay, we have the phase and the neutral wires, which are sent to the switchboard. And for these power plugs, we also have one more wire called the earth wire. So we actually have three wires: the phase, the neutral, and the earth wires that are given to the plug. And we know to the power card, okay, so you have three terminals at the power card: the phase, neutral, and the earth terminal. So within the power card, this is how the connection is made. So most of the power cards have an inbuilt fuse to it, and this is how the terminals are being powered through the flux or the cable. And in order to avoid the cable from moving around, you have a cable grip also. So now let me explain the wiring between the socket and the switch. So we have the switch and the socket. So we are going to talk only about three terminals: the phase, the neutral, and the earth terminal. And hence I just have represented three pins in my socket. Whenever you have the phase line coming from the MCB, that is given to the switch. The other end of the switch is connected to one of the terminals of the socket, and we also have the neutral wire coming out of the circuit breaker. So that is given to the other pin of the socket. And the third pin, earth pin, is having a larger dimension so that it offers minimum resistance to the flow of earth leakage current. So earth pin is connected to the largest socket. So this is how we generally wire. But what if we have a fuse, an indicator, a switch, and a socket within the switchboard? So let me explain two scenarios. The first scenario where the indicator is on only when the switch is on. Okay. So first, okay, let me have the wires. So I have the phase wire, and then we have the neutral, and we also have the earth wire, right? So let me start from the phase. Phase wire is given to the fuse. The other end of the fuse is connected to the switch. The other end of the switch is now connected to the socket, like how we have seen earlier. Okay, and now this socket's terminal is now connected to one of the terminals of the indicator. And now from the neutral, okay, we have connections to one pin of the socket and also to the indicator. And finally, we have the earth wire, which is connected to the earth pin of the socket. So this is how we connect, and the indicator is on whenever the switch is on. So whenever I close the switch, okay, so as you could see here, current flows, sorry. So whenever the switch is on, the current flows to the switch and also to the indicator, and there occurs a conduction. Okay, so now over to the second scenario where the indicator is always on. Either the load is on or off, either you switch on the circuit or off the circuit, your indicator is always on. So for that, from the phase wire, we connect the fuse. The other end of the fuse is connected to the switch, and the other end of the switch is connected only to the pin of the socket. And from the fuse itself, we connect one terminal of the indicator. And we have the neutral connected to the other pin, that is the neutral pin of the socket, and to the indicator. And as seen earlier, we also have a connection to the earth pin. The earth wire is connected to the earth pin. So this is how we connect the switchboard with a power socket and an indicator. And here in this circuit, always the indicator is on. That is, the supply comes from the phase wire, okay, and then it goes to the switch, and there is continuity of supply only if the switch is on. Okay, else no continuity is there and load is not on. But here always current flows through the indicator. So this path is always active, and thus the indicator is on always. So this form of wiring could be used for the geyser, refrigerator, oven, mixie, grinder. Okay, so for all such applications, such wiring could be used. Thank you.